ఈ పాప ఏమైంది నాకు తెలిస్తే నేనేమైనా మాట్లాడాను.
Good evening, sir.
Good evening, Javian. How are you?
I'm good, sir. How are you?
Fine, Javian. Okay. So in last class, we are discussing about the solutions and solubility of the gases in a liquids, na? Right now.
Yes, sir.
Next, I'm going to continue the class here. Okay, I don't want to
sir.
waste your time. So here, first, based on the pressure, already we explained the solubility. Okay, so based on the pressure, we already explained the solubility. So what is the relationship between the pressure and solubility of the gases in a liquids means here? So pressure is directly proportional to solubility of the gases in a liquids. Okay, so pressure is here directly proportional to solubility of the gases in a liquids. Okay, and what is the second one here? What is the factor? Temperature, nature of the gases also. Okay, so nature of the gases also, it shows the effect on the solubility of the gases in a liquids. Okay, so here the gases
Yes,
which
sir.
are easily liquefied, those gases are highly soluble in a water. Okay, the gases which are less which are not easily liquefied, that gases cannot be soluble in a water. One second, ma. Okay, and what about the temperature here? Temperature, what is the relation temperature? Yesterday I'm talking about this one only. Okay, yesterday we are discussing about this concept only. Temperature, what is the relationship between the temperature and solubility of the gases in a liquids? Okay, so temperature and solubility of the gases in a liquids is inversely proportional. If the temperature is going to be increases, means solubility of the gases in a liquids is going to be decreases, because of the solubility of the gases in a liquids is exothermic in nature. Okay, it is exothermic in nature. So due to that reason only, here if the temperature is going to be increases, means solubility of the gases in the liquids is going to be decreases. Now you got the clarity, all of you. Next, here what is the main concept we are having means here? Vapor pressure. So today just I'm going to be complete the concepts here. I want to complete all the concepts. Okay, so tomorrow we will discuss questions based on this one. I don't want to waste more time. Okay, now, so here vapor pressure, vaporization. So what is mean by the vaporization, ma? What is mean by vaporization? Any one of you?
Like, so turning liquid into vapor
Okay.
state.
Like the liquid is turning into the gases form here. Okay, if the liquids are converted into the gases form at room temperature is called as a vaporization. Okay, so generally we can call as evaporation also. Evaporation means will takes place at room temperature. By increasing of the temperature, if the liquid is converted into the gases form, in that we can call as a vaporization. Okay, here what are the factors affecting the vaporization means here? One is surface area. Surface area. If the surface area is increases, vaporization also is going to be increases. Okay, so what is the simple example that one means here? If you want to check it out, means this is a summer season. In summer season, if you observe in rivers, okay, in rivers, canals and all, means water is partially undergoes to evaporated. Okay, and water levels are going to be decreases in rivers and canals in summer season only. Why? What is the reason why the summer season or water levels are decreases in canals and rivers, ma?
Because of the heat, so like the top layer of the water becomes extremely hot and it turns into vapors and it
Very
goes
good,
up,
very good,
which
Javan.
decreases the water levels.
Very good, Javan. So because of at the same time, if you see means rivers, canals are having more surface area. Because of their length, river length, it will be more. Okay, river length is more means it is exposed to the sunlight. Okay, whenever it is exposed to the sunlight means here the kinetic energy of the liquid molecules are going to be increases. then they're easily, the surface of the liquid molecules are easily converted into the gases by increasing of the temperature. So due to that reason only, in reverse canals, water levels are drastic, they are going to be decreases. Okay, and what is the another one means here, based on the nature of the solute. Okay, nature of solute. So that means we have a different types of the solutes are there. Okay, so highly volatile liquids are there. Volatile liquids. Volatile liquids. So what is meant by the volatile liquids? What is meant by the volatile liquids, ma? The liquids which are easily converted into the gaseous form, that kind of liquids are called as here volatile liquids. Okay, the liquids which are easily converted into the gaseous form, that kind of liquids are called as here volatile liquids. Okay, so what are the examples for this one means here? Alcohols, ethers, acetone, all these are the examples of the volatile liquids here. Okay, sir, in that also alcohols, what is the best example means here? Body deodorants are the one of the best example for the volatile liquids. Hope so everyone they are using as a body deodorants or perfumes and at all. So whenever you're going to spray body deodorants on your clothes, within a fraction of seconds, they converted into the gases form only. Is it right or not? Okay.
Yes, sir.
Right, ma'am. So volatile liquids are having high vaporization. Easily they converted into the gaseous form. Yeah, at room temperature only they are converted into the gaseous form. And water and at all itself, some liquids are there. So by increasing of the temperature, the liquids are converted into the gaseous form. So those are we can call as a non-volatile liquid. So based on the nature of the solute also, so vaporization also it is depends upon the nature of the solute. So one is the surface area, second one is nature of the solute, and third one temperature. What is the third factor means here? Temperature. Okay, the temperature is going to be increases. So vaporization also is going to be increases. Temperature is going to be increases means vaporization also is going to be increases. Okay, and one more term it is there. So vapor pressure. Vapor pressure. Okay, so sometimes they're asking JEE level, they're asking the question mark. In vaporization process, what about the delta G? So delta G is nothing but spontaneous process. Sir, when we can call it as a spontaneous, non-spontaneous means if the delta G value is negative, if the delta G value is negative means then only we can call it as here spontaneous process. Okay, spontaneous process. So vaporization process is the spontaneous process. Okay, so this also we can explain based on delta G, also we can explain based on delta H minus of T into delta S. So generally we can call it as a Gibbs free energy formula. So what is the formula means here? Based on Gibbs free energy formula also we can explain either the given reaction is spontaneous or non-spontaneous. Okay, now one more. So what is mean by the vapor pressure? What is mean by the vapor pressure? What is mean by the vapor pressure? What is mean by vapor pressure? So what is mean by the vapor pressure means the pressure exerted by the gaseous molecules on the surface of the liquid is called as a vapor pressure. So what is meant by the vapor pressure, ma? So vapor pressure is nothing but here, it is the pressure exerted by the gaseous molecules on the surface of the liquid is called as a vapor pressure. Now you got the clarity? Still anyone having doubt here? Okay, so here some terms are there. Okay, vapor pressure, vaporization. Okay, so vapor pressure is independent on the surface area. So vapor pressure is independent on surface area. Independent on surface area. Surface area. So vapor pressure is independent on the surface area. And vapor pressure is directly proportional to the temperature. If the temperature is going to be increases, means vapor pressure also is going to be increases. Okay, so these two factors also very important. Sometimes they're asking the question. So vapor pressure is either depends upon the surface area, means it is not depends upon the surface area. It is independent on the surface area. Okay, and vapor pressure is directly proportional to the temperature. If the temperature is going to be increases, means vapor pressure also is going to be increases. So based on this one, vapor pressure and all, they are explained by the Raoult's law. Vapor pressure and all, they are explained here, Raoult's law. Okay, so Raoult's law. So what is mean by the Raoult's law? Raoults. So what is mean by the Raoult's law? What it explains? Raoult's law. So Raoult's law is, it explains vapor pressure of the solution. It explains about here vapor pressure of solution. Okay, it explains here about the vapor pressure of the solution. Okay, so in vapor as a solution, what is meant by the solution? Solution is nothing but mixture of components only now. Okay, in this one we are talking about the we have two types of the solution. The solution which contains the non-volatile solute and volatile solute. Okay, so one is volatile solute, it will be there in a solution. Another one is non-volatile solute, it will be there. Okay, so that it is going to be explained. So according to the Raoult's law, the vapor pressure of the solution which contains non-volatile solute, volatile solute. First, I'm going to be explaining here volatile solution. Volatile solution. If the volatile solutions are having more vapor pressure or less vapor pressure? Volatile solutions are having more vapor pressure or less vapor pressure? Volatile solutions are having more vapor pressure or less vapor pressure? Tell me, ma. Any one of you? Which are having high vapor pressure? Either volatile. Simply for that one, I'll ask one question. Is alcohols are having high vapor pressure or water is having high vapor pressure? Is alcohols are having high vapor pressure or water is having high vapor pressure? Javion, Sriyuta.
Yes, sir.
So which one is having high vapor pressure?
Volatile solution, no?
Volatile solutions are having high vapor pressure. Simply, ma. So what is the, actually I think so either you're observing or not. So whenever you're shaking the body deodorant bottles here, so internal pressure is going to be increases. Internal pressure is going to be increases. Otherwise, same liquid if you place in the bottle and if you shake the water, means internal pressure is going to be increases or decreases. I think so you can't observe that much of difference while taking the water. But in body deodorants, alcohols means here, whenever you are shaking, internal pressure is going to be increases. Okay, so that's why volatile liquids are having high vapor pressure because of liquids are easily converted into the gaseous form. Okay, so because of liquids are easily converted into the liquids form. So that's why that causes a high vapor pressure. Okay, now let's see. According to that one, so the vapor pressure of the solution, the vapor pressure of solution, vapor pressure of solution is equal to, it is the product of vapor pressure of the pure component into mole fraction of the component. Okay, so that what we can write as here. So how we can define the, so Raoult's law means here for volatile solution at given temperature or at constant temperature, the vapor pressure of the solution is equal to, so vapor pressure of, it is a product of vapor pressure of the pure component and so mole fraction of the component is called as a vapor pressure of the solution. So because of why I'm writing like this means solution is a mixture of component, is a solute also volatile. That means we can write as a P naught A. Let us consider A is the solute. Okay, A is the solute means we can write as a P naught A into XA also we can write the vapor pressure of the solution, and vapor pressure of the solution also depends upon here P naught B into XB also we can write. So P naught B into XB also we can write here. Okay, so now based on this one P solution. Okay, so any component also is dependent. If we take any component, so it is going to be depends upon the component of the vapor pressure of the pure component and mole fraction of the component. Okay, but Same concept we can't apply for non-volatile solutions. Okay, so the solutions which contain non-volatile solute, non-volatile solute. The concept is not applicable for the solutions which contains non-volatile solute. So why the concept is not applicable for the non-volatile solute means here, let us see first what I'm telling that means here. First I'm taking as a one container. In container, I took as a solvent. Okay, first I took as a solvent. So whenever you are heating, let us see if the solvent, whenever you are going to increase the temperature, the solvent is easily converted into the gaseous form. If the number of gaseous molecules are increases on the surface of the liquid means vapor pressure is going to be increases. Okay, now whenever you are adding as a non-volatile solute, non volatile solute. Whenever we are adding as here non-volatile solute. So whenever you add as a non-volatile solute, some of the solvent molecules are replaced by the solute. Okay, some of the solvent molecules are replaced by the solute means the gaseous molecules are less only na. Okay, very less amount of the liquid is converted into the gas. That means if the gases molecules are reduces means vapor pressure also is going to be decreases. Okay, so vapor pressure also is going to be decreases. So in this one, the vapor pressure is depends upon the solute or solution solvent mark. In the second condition, the vapor pressure is depends upon solute or solvent. If you add non-volatile solute means vapor pressure is going to be decreases. If pure solvent is that means it has a high vapor pressure. It has high vapor pressure. So that means the vapor pressure is okay. The vapor pressure or partial pressure of vapor pressure of solution is the vapor pressure of solution is depends upon the vapor pressure of the pure solvent. That means we can write as a so pure vapor pressure of the pure solvent and mole fraction of the solvent So this concept is applicable for non-volatile solute. Okay, so is that clear? So anyone you having doubt here? Okay, actually, Raoult's law is applicable for only very dilute solutions. Okay, Raoult's law is applicable for dilute solutions. Okay, and whatever the solute we are taking, that it does not undergoes to the association or dissociation. Okay, dissociation. The solute whatever we are adding in the solvent, that it does not undergoes to the association and dissociation. So actually Raoult's law is applicable for dilute solutions only. Okay, concentrated solutions also we can apply, but say this is a concept is more applicable for dilute solutions. Now you got the clarity. So based on this one we are going to be explain ideal solutions and non-ideal solutions. Okay, so based on this one, we are going to explain here ideal solutions and non-ideal solutions. Do you have any idea about that one? What is meant by the ideal solutions and what is meant by the non-ideal solutions? Anyone you having idea?
The ideal solution is like which follows Raoult's law, right? And non-ideal solution will not follow
Very good.
Raoult's law.
Yes. Okay. Just 1 second. Just a second. I want to show something, that's why I'm clicking here. Okay. Then I'm going to share the screen. I want to share the screen here. Right, now I've got the screen here. Now I'm going to share the screen because of I can't write all the points. Okay. Now I'm going to share the screen. So all of you got the screen?
Yes, sir.
Okay, everyone. Now let's see. So here, so based on the Raoult's law, we are going to be explaining the solutions. Okay, so actually solutions are classified into two types. Okay, what are the two types of the solutions we are having means here? Ideal solutions and non-ideal solution. Okay, so first one you can see here. So what is meant by the ideal solutions means here? Solutions which obeys Raoult's law at all temperatures and concentrations is called as here ideal solutions. So what is meant by the ideal solutions here? The solution which obeys Raoult's law at all temperatures and concentrations is called as here ideal solution. Okay, for sir, which type of solutions are they exhibit as an ideal solution means here? For ideal solution, in between the solute and solvent, okay, they have a similar intermolecular attraction forces. In ideal solutions, solute and solvent are having similar intermolecular attraction forces. Okay, so whenever the solute and solvent are dissolved in a water, so there is no change in enthalpy. Okay, heat is not going to be releases and heat is not absorbing. Okay, so that's why change in enthalpy mix what we can write means is equal to 0. That means neither heat energy is going to be releases nor heat energy is going to be absorbed for the ideal solution. And change in volume. Okay, so change in volume also is not going to be changed. If the change in volume also is not going to be changed, means that we are going to represent delta V mix is equal to 0. Okay, so this is the graphical representation. So generally, the ideal solutions we are going to be represent like this here. Okay, so in this one, the total pressure. So because of in this one, P1 it represents as a solute and P2 is represent as a solvent here. Then total pressure, because of the vapor pressure of the solution is depends upon the partial pressure of the components present in a solution. Okay, hence we can call as a total pressure is equal to partial pressure of the solute plus partial pressure of the solvent. Sir, how we are going to be explaining this one means here based on so Dalton's law here. Okay, so did you remember the Dalton's law? Actually, they deleted the concept states of matter is deleted. Dalton's law is in states of matter. Okay, so how we can define the total pressure means here at given temperature, the total pressure of the mixture of chemically non-reacting gases is equal to sum of the partial pressure of the gases. Sum of partial pressure of the gases. Okay, so the vapor total pressure of the mixture of chemically non-reacting gases is equal to it is sum of partial pressure of the gases present in a container is called as a Dalton's law. That is only we can represent as a P total is equal to P1 plus P2 we can write as here. Okay, similarly same concept also we are applying for the Raoult's law. Here also total pressure we are taking as a P1 plus P2. In this one, P1 is the partial pressure of the solute and partial pressure of the solvent. For ideal solution, total pressure is equal to it is the partial pressure of the solute and solvent. That's why we can write as a P1 plus P2. Clear? Right. So why they exhibit as the same means here? Because of they having the similar intermolecular attraction forces. They have here similar intermolecular attraction forces. How they're asking the questions in the examination part means here based on the examples, they're asking the questions in the examination part. So what are the examples of the ideal solutions? Means benzene, toluene. Let's see, here they had given us a list of the elements. So benzene, toluene is that as a, so it is the example of the ideal solution. Ethyl bromide, ethyl chloride, N-heptane, N-hexane, chlorobenzene, bromobenzene, ethyl chloride, and ethylene bromide. Okay, so this is also one of the example of here ideal solution. Again, one more it is that non-ideal solution. Sir, what is mean by the non-ideal solutions? Means here a solution which does not obey Raoult's law at all temperatures and concentration is called as a non-ideal solutions. For non-ideal solution, delta H mix is not equal to 0. Delta V mix is not equal to 0. Okay, delta H mix is not equal to 0. Delta V mix is not equal to 0. Okay, so based on that one, that means in total pressure also is not equal to sum of the partial pressure of the P1 plus P2. Okay, so based on that one, again we can explain. So again, non-ideal solutions are classified into two types. So one is positive deviation non-ideal solutions and negative deviation non-ideal solutions. Okay, so one is positive deviation non-ideal solution and negative deviation non-ideal solution. Okay, so what is meant by the positive deviation non-ideal solution? So how we can define means here, in positive deviation non-ideal solution, solute, solvent, solvent. That means solute particles are having high intermolecular attraction forces and solvents are having high intermolecular attraction forces while comparing with the solute and solvent. Okay, so while comparing with the solute and solvent, that time what happened? Vapor pressure here. Okay, so in this one, what happened here? Whenever here solute, solvent means here it cannot form as a solution. That means we can call it as a partially soluble. Partially soluble liquids are there here. Okay, so partially soluble liquids are having, okay, so low vapor, high vapor pressure. So to convert into the solute, we have to apply more heat energy. Then only the bonds between the solute and solvent are going to be break, and solute and solvent are combining together. Okay, so in this one, first we observe the graph now. Whatever the dotted lines are there, the dotted lines are represent the ideal solutions. Whatever the dotted lines are there, that all dotted lines are they represent as a ideal solution. But whenever you're applying the heat energy, okay, or if you take the vapor pressure, okay, by increasing the heat energy, vapor pressure also is going to be increases. Na? So vapor pressure is going to be increases, means that we are going to represent above the line. Okay, above the line to the Raoult's law. Okay, so according to that one, what about the change in enthalpy? Enthalpy means you are applying the heat energy. If you are applying the heat energy, means change in enthalpy, it becomes as a positive or negative. The given reaction is endothermic reaction. If the endothermic reaction is, what is the change in enthalpy? Delta H value. Samhita J.
Sure.
What is the change in enthalpy value for the endothermic reactions, ma'am?
So it will be positive.
Very good, ma'am. It is positive. Greater than 0 you are getting. Okay, water is going to be boils at 100 degrees centigrade. Water is going to be boils at 100 degrees centigrade means it is positive. If it is positive means delta H is greater than 0. Okay, and change in volume. If the liquids are converted to the gases form means volume also is going to be changed. So that time, so volume also greater than 0. For B positive deviation non-ideal solution, change in enthalpy it becomes as a positive. Change in volume also it becomes as a positive. Sir, what are the examples for the positive deviation non-ideal solutions? Means here carbon tetrachloride benzene, carbon tetrachloride chloroform, carbon tetrachloride toluene, acetone carbon disulfide, acetone ethyl alcohol, acetone benzene, methyl alcohol water, ethyl alcohol water. All these are the examples. All these are the examples of here positive deviation non-ideal solution. So examples are very important here. Examples are very important because of in some books their NCERT textbook they had given us a less number of examples. Okay, so better to go for the reference books to get us a more number of examples. Okay, so based on the examples only they are asking the question. Yeah. and negative deviation non-ideal solution. Okay, so negative deviation non-ideal. So anyone you having doubt here, sir, why the methyl alcohol water is the positive deviation non-ideal solution? Do you have any idea? For that one, I'll give one clarity more. The boiling point temperatures are going to be decreases. Actually, methyl alcohol, ethyl alcohol, they're highly volatile. Okay, at less boiling point temperature only, at low temperature only, they are going to be boils. But whenever methanol or ethanol, if you add in a water, the boiling point temperature of the alcohol is going to be increased. Sir, how the boiling point temperature of the alcohols are going to be increases means in this one what happened? In between, they form as a methyl alcohol. Ethyl alcohols are they form as a strong bonds. They form as here strong bonds. Whenever they form as a strong bonds means we have to apply the more energy now to break the bonds here. Okay, so due to that reason only, ethyl alcohol plus water, methyl alcohol plus water, they form as a positive deviation non-ideal solution. Okay, and negative deviation non-ideal solution. What is meant with the negative deviation non-ideal solution? Means here, negative deviation non-ideal solution. AB intermolecular attraction forces are intermolecular attraction forces are greater than that of the AA and BB. That means solution is having in a solution, solute solvent are having strong intermolecular attraction forces than that of solute and solvent. In negative deviation non-ideal solution, delta H is negative and delta V mix also it becomes as a negative, and total pressure also less than. Total pressure also is less than partial pressures. Okay, so total pressure also is less than here partial pressures. So that's why how we are going to represent my here. How we are going to represent here diagrammatically based on sometimes they're asking the diagrams also. That's why I'm showing as a diagram. So in diagrammatically what happened? Dotted lines are represented as a Raoult's law, and we are writing as a downside. That means vapor pressure is going to be decreases. Vapor pressure is going to be decreases. So what is the best example why the delta H it becomes as a negative? All of you done the practicals? Everyone? All of
Yes,
you?
sir.
Okay. So in while doing the practicals, I think so salt analysis part, have you done nitration test?
Yes, sir.
Yes.
In nitration test, what you are taking here for the salt, you are adding as a concentrated sulfuric acid now.
Yes, sir.
So when the concentrated sulfuric acid is reacts with the salts means test tube it becomes as a so hot. Have you observed or not?
Yes, sir.
Okay, and when the concentrated sulfuric acid is dissolved in a water also, that time also it releases more heat energy, solubility test also. Okay, so releasing of heat energy is called as exothermic nature. Releasing of heat energy is called as exothermic nature. So that's why what are the best examples we can take for the negative deviation non-ideal solution means water plus HNO3. Okay, so water plus HCl also we can take here. Water plus sulfuric acid also we can take as here negative deviation non-ideal solution. Clear? And one more also it is the azeotropic mixture. Based on azeotropic mixture also they're asking the questions here. What is meant by the azeotropic mixture means here they have given. So what is meant by the azeotropic mixture means solution. Solution is nothing but mixture of components. Solute and solvent. Both the solute, the mixture of components are they act as a real solution. At the same boiling, at the same temperature only they boils. Okay, the mixture of liquids boils at the same temperature without changing their composition. Okay, without changing their composition are called as here azeotropic mixture. Okay, azeotropic mixture also we can call as a real solutions. Okay, azeotropic mixture also we can call as a real solution. Sir, what is the best example for the real solutions means here? Once alcohol, if it dissolve in a water means it gives as a uniform solution. Or one more, HCl and water. If you dissolve the HCl in water means it becomes as a real solution only. We cannot separate the HCl and water. Okay, we cannot separate the HCl and water. They boils at the same temperature. Okay, actually HCl is highly volatile. If you open the lids of the HCl means continuously it releases the fumes. Hydrogen chloride fumes are going to be increases. Okay, but whenever you dissolve the HCl in a water, the fumes are going to be decreases, and it becomes as a non-volatile solution because of it forms as a strong bonds with the water molecule. Okay, then actually water is going to be boiled at 100 degrees, 100 degrees Celsius. Pure HCl is boiled at less than 100 degrees centigrade. But whenever you add HCl in the water means automatically the boiling point temperature is going to be changes. Both liquids are boiled at one particular temperature. That one particular temperature only we can call as here azeotropic mixture. Okay, again azeotropic mixtures are classified into two types. How many types here? Two types. Minimum boiling azeotropic mixture and maximum boiling azeotropic mixture. Okay, exactly opposite, directly opposite statement we can take. Minimum boiling azeotropic mixtures are the best examples of positive deviation non-ideal solution. Because of positive deviation non-ideal solutions, are they're having high vapor pressure. While having the high vapor pressure at low temperature only, they are going to be boils. Okay, and negative deviation non-ideal solutions. Okay, maximum boiling azeotropic mixture. What is the best example for the maximum boiling azeotropic mixture means here? Negative deviation non-ideal solution. Okay, so because of we have to apply the more heat energy here, that means they're having the low vapor pressure. They're having here low vapor pressure. Whenever they're having the low vapor pressure, okay, so we have to apply some energy. Okay, so that's why maximum boiling azeotropic. What are the examples of the maximum boiling azeotropic mixture? Yeah, negative deviation non-ideal solution. Okay, so what are the minimum boiling azeotropic mixture means here? Positive deviation non-ideal solutions are the example of here. So for minimum boiling azeotropic mixture. For that one, what are the examples are there? Same examples only we can write. Okay, what are the examples we had seen now? Same examples only we can see. We can write here. Okay, based on the examples in JEE level and NEET level also they're asking the questions. Examples only they're asking the question. They are not asking any theory part, they're not asking any conceptual part. They're giving some examples. Okay, so the given example is either it is an ideal solution or non-ideal solution. Non-ideal solution also positive deviation or negative deviation non-ideal solution. Directly they're asking the question. Got it? Okay, so today I'm going to forward some assignment based on this one. You have to solve the questions. Okay, yesterday I didn't complete the main concept, that's why I didn't forward. And what is another main concept means here? Colligative properties. Okay, colligative properties. Based on the colligative properties in JEE level, everywhere they're asking the numericals part only. Okay, so what is meant by the colligative properties means here? First, we are taking as a solvent water. What are the properties of the water? Any one of you can tell me that? Just I want to give on some example. What are the properties of the water? Everyone, we are having the water. Without water, it is not possible to survive. Is it right? What are the characteristic properties of the water? Javian is giving the answer. Javian, come on.
So like it can take any shape and size and
Sir, it's polar and it's a good solvent.
Very good. General characters, they are not telling that. Daily we are seeing water, we are having much. Is water is color ma? Is water is any color it is there? Is water
No,
is having
sir.
any color? No ma. Okay.
No.
And is any odor it is there for water?
No, sir.
So water is colorless, odorless, tasteless. Water is colorless, odorless, tasteless. But you may get the doubt. Sir, whenever we are having water, we are getting some taste. So how you are getting as a taste means here, based on some, if you see in water nowadays, we are using as a mineral water. In mineral water, they are mixing some chlorine. Otherwise, if we use RO filters also at home also, in RO filters also, we are using as a chlorine. That is only we can call as a chlorinated water we are taking. So whenever you take as a chlorinated water means we will get some taste. Okay. So at the same time, if you see some villages and at all, they'll mix some bleaching powder. Water also gives some bleaching powder smell, and the taste also it is completely different. Bleaching powder also it acts as a oxidizing agent. It kills the microorganisms which are present in your water. Okay, so whenever you are adding some of the substance means the properties of the solution is going to be changed. For example, Water is telling that colorless, tasteless, odorless. Whenever you add sugar in your water, you will get as a sweet in taste. In that, if you add some salt, you will get as a salty water. Okay, so whenever you're adding as a solute means the properties of the solution is going to be changed. Okay, whatever the properties are going to be changed, that properties only we can call as a colligative properties. Okay, the properties of the solution is depends upon the number of solute particles irrespective of their nature. Either it may be ionic or either it may be covalent. Okay, so it is not going to be considered. Okay, irrespective of their nature, the number of solute particles are increases means, okay, the properties also is going to be changed. What are the properties we are going to be discussed means here? Let's see directly they had given. Okay, so what are the 4 properties we are going to be discussed means here? Relative lowering vapor pressure, elevation in boiling point temperature, depression of freezing point temperature, osmotic pressure. Okay, so what are the colligative properties we are going to be discussed means here? We are going to discuss about the relative lowering vapor pressure, elevation of boiling point temperature, depression of the freezing point, and osmotic pressure. Okay, so briefly I'm going to be explaining here. Is any explanation you want here? They're asking the calculation part mark. Okay, if I want to explain means, I think so 2 more classes also it's not sufficient to you to explain full chapter. Okay, so that's why this main exam point of view concepts only I'm going to be explaining. Sir, what is the formula for the relative lowering vapor pressure means here? P naught minus P by P naught is equal to excess. Excess is nothing but so mole fraction of the solute. Okay, so P naught in this one, P naught is nothing but vapor pressure of the pure solvent, and P is nothing but vapor pressure of the solution. Okay, and excess is nothing but mole fraction of the solute. If you simplify the formula means we'll get P naught minus P by P naught is equal to NS by N naught plus NS. In this one, N naught is nothing but number of moles of the solute. Okay, for dilute solution, because of colligative properties which we are taking as a dilute solution. In a dilute solution, denominator number of moles of the solute is going to be negligible. If the number of moles of the solute is going to be negligible, maybe we can write as a formula is P naught minus P by P naught is equal to A by M into W by B. In this one, what is meant by the A means here? A is nothing but mass of the solute. Capital M is nothing but molar mass of the solute. Okay, and W is nothing but weight of the solvent, and B is nothing but molar mass of the solvent. Okay, so based on that one, we are having some of the calculations, and somebody they left the group. Javian, he left the group. Okay, and remaining all. So Anama, anyway, can I explain remaining part tomorrow?
Yes, sir.
Okay, sir.
Okay, so today I'm going to be forward some assignment. First to go through the formulas. Okay, we can solve some questions here. According to that, if you're having any doubt, we'll discuss also. Tomorrow I'm going to finish this chapter. Okay, so next I'm going to start the new chapter. Is that okay?
Yes, sir.
Okay, next we'll go for the electrochemistry, which is interlinked to this chapter. Because of redox reactions, I finished. Redox reactions is interlinked to the electrochemistry. If the 2 chapters are finished means until these 4 chapters we covered. Some basic concepts of chemistry, redox, interlinked chapters are going to be finished. Okay?
Okay, sir.
Then we'll continue tomorrow. So thank you all.
Thank you, sir. Thank you, sir.
Thank you.